Light travels in straight lines. No, it doesn't. It's a wave. For the longest time, people were debating and arguing between wave and a particle of light. Isaac Newton famously supported the particle theory. And for many centuries, a lot of people backed him up, until the infamous demonstration of Young's split experiment. Here we have a schematic of the experiment. If light travels in straight lines, there would only be two sources of light coming through. But what actually happens is that you get an interesting spectrum. You get dark and really light spots. In fact, there is a fascinating equation that's derived from it. N lambda is equal to d sine theta. Lambda standing for the wavelength of light. This was really important because using this experiment at the time, they were actually able to calculate the average wavelength of white light. D is the distance between the slits, which you can adjust to get different data. And sine theta is the angle between the normal and one of the constructive interference spots. N is which constructive interference from the normal you're in. I mentioned this interesting term, constructive interference. What does that mean? Well, when two light rays match up perfectly together, they build up in a constructive interference. Basically, at any given point, you add their amplitudes. And so their brightness basically gets maximized. However, another thing can happen, and this represents the dark spots. This is where destructive interference occurs. When these two waves meet, they're in opposite directions and so completely destroy each other, and there is no net light ray.